learning about trigonometric identities. Can someone remind us why these identities are important?
Good question. Trigonometric identities help us simplify expressions, transform one function to another, and solve equations. These are also useful to real-life world application, like in physics and engineering.
Right. For example, in electrical engineering, sine and cosine functions describe alternating current waveforms. Using identities helps simplify complex calculations.
That makes sense. Let's apply a fundamental identity to express one trigonometric function in terms of another. How can we express sine squared theta in terms of cosine squared theta?
We use the Pythagorean theorem. Sine squared theta plus cosine squared theta is equals to 1. If we isolate sine squared theta, we get sine squared theta is equal to 1 minus cosine squared theta.
That's a great example. Here's another. How can we express tan theta in terms of sine theta and cosine theta?
So we recall the quotient identity. Tan theta is equal to sine theta over cosine theta. This is useful when solving equations involving tangent function because we can write them in terms of sine and cosine.
Let's try to prove an identity. How about this one? 1 plus tan squared theta is equal to secant squared theta.
That's a classic identity. Let's start from the Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. Now let's divide everything by cosine squared theta to transform it.
Good strategy. Sine squared theta over cosine squared theta plus cosine squared theta plus over cosine squared theta is equal to 1 over cosine squared theta. Since sine theta is over cosine theta is tan squared theta and 1 over cosine theta is secant squared theta, we get tan squared theta plus 1 is equal to secant squared theta.
That's correct. This proof is helpful when working with secant and tangent functions and solving equations.
Here's a question. Why do we prefer proving an identity using algebraic manipulation rather than plugging in values?
Here's a challenge. If we know that sine theta is equal to 4 over 5, how can we find that theta?
We use the Pythagorean theorem again. Sine squared theta plus cosine squared theta is equals to 1. Substituting cosine squared is equal to 3 over 5, we solve for sine squared theta. Sine squared theta plus cosine squared theta is equals to 1. Then sine squared theta plus 3 over 5 squared is equals to 1. Sine squared theta plus 9 over 25 is equal to 1. And then sine squared theta is equal to 1 minus 9 over 25 is equal to 16 over 25. Then sine theta is equal to 4 over 5.
Since theta is in the first quadrant, sine is positive, so sin theta equals 4 over 5. That was straightforward using identities.
This discussion really showed how trigonometric identities simplify expression, prove relations, and solve problems.
And the ability to prove identity strengthens our problem-solving skills.
Exactly. Let's practice more so we can apply these concepts in more advanced problems.